2:45. Hello, everyone. Welcome to our panel here. To get us started, I'm going to hand us over to Megan Sykes from Northeastern University to introduce the panel.
All right. Thanks, Shivani, and hello, everyone. I'm so excited that you are all joining us today for our panel on navigating the different fields of data. As Shivani said, my name is Megan Sykes, and I work at Northeastern University Seattle campus. And with nearly 1,000 learners located at our South Lake Union campus, Northeastern has always been committed to increasing the number of women in STEM fields, including creating and supporting more inclusive pathways for women into data science. As part of that commitment, we are honored to sponsor this conference this year. And on behalf of Northeastern, thank you for being here, supporting the WiDS Puget Sound Conference, and networking with your fellow data enthusiasts. We're just so humbled to share this space with you all. So quickly before we get into it, I'll go over some logistics for today's panel. We will have the opportunity to hear from our wonderful panelists for roughly 40 minutes or so before opening up to our Q&A. So please post your questions to the Q&A box and not the chat. If you would like your question directed to a specific panelist, please include their name in your question. We'll make sure to direct it to them. You can also upvote the questions you want to see answered once we open the Q&A portion of the program. So now I'm going to happily hand it over to our incredible moderator for today's panel and an alum of our analytics program here at Northeastern University, Trupti Shah. Trupti, take it away.
Thank you, Megan. Hello, everyone. Good afternoon. Welcome and thank you for investing your time with us on a Monday afternoon. My name is Trupti and I will be moderating today's panel. As Megan mentioned, a bit about myself. I'm a Strategic Analytics Associate, currently working at Northeastern University Seattle, and I'm also a proud Northeastern alumni. I work on different analytics projects to help the leadership make data-driven decisions. Today, we have an amazing panel on navigating the different fields of data from a higher education perspective, where we will be focusing on identifying the different definitions of data science and discussing the need for a diversity of skills in data, from data collection to data engineering, statistical analysis, computational design to algorithm development. The all-women panel consists of instructors from 3 graduate data-related programs, and we will be discussing the differences between data science, data engineering, and data analytics. Our incredible panelists, Dr. Adrienne Slaughter, Dr. Amanda Welsh, and Shivani Patel, who are leading experts in the data field, have been invited to share their experiences and educational journey in data science. Our goal today is to help you find your fit into the data science, because we all come from different backgrounds and interests. So talking about today's agenda, as Megan mentioned, we will be having a panel discussion for about 40 minutes, and rest of the time will be open for the Q&A. So to start with, I would like the panelists to introduce themselves and tell us a bit more about what influenced them to pursue a career in data science. Adrienne, would you like to kick it off?
Sure. Thank you, Trupti, and thanks for having me. I'm happy to be here. I am an assistant clinical professor at Northeastern here on the Seattle campus. I'm in the Curry School of Computing. I've been here for about 3 years, and I got into data science through doing my PhD. I did my PhD at the University of Washington and finished maybe 7, 8 years ago or something-ish around there. And that's where I really became enamored with what data could tell us about people in so many ways. There's the type of data instruments that you can use to gather information and see trends over a community. You can collect sensor data and see what activities someone's doing over time, and that is what has driven my interest and experience in data science.
Thank you so much. Shivani, would you like to go next?
Sure. So I ended up in data science through a really winding field. I first did my undergraduate work in speech and hearing sciences, and I realized that while I really enjoyed the theory of speech and hearing science and working with people who were either had traumatic brain injury or other speech and hearing disorders, I didn't like the application as much as I thought I would. And I found that out my senior year at University of Washington when I was completing my honors thesis. And after that, I actually slowly found my way to data science. I wasn't sure what I was going to do next, so I slowly started taking classes at community college. I went back to the beginning and I took my first math class in almost 6 years, and I took calculus and restarted just slowly, one class at a time, proving to myself that I could do it. And I ended up, over the course of the next 7 years after leaving University of Washington with an undergraduate degree, ended up finishing my master's in statistics from Oregon State. And I found my way to data science by realizing each step along the way a little bit more about how I wanted to apply my passion for math and statistics. And so at first I thought it was maybe going to be teaching full time. I thought maybe a traditional statistician role, and I was lucky to get an internship at SAP Concur where I was able to do some machine learning work and model deployment. And it ended up being that ML was the sweet spot for me. And I still get to teach now, which is really exciting and one of the things that I always loved. And so I'm an adjunct lecturer in the College of Engineering for the Master's in Data Analytics Engineering.
That's amazing. Thank you so much, Shivani. Amanda, would you like to introduce yourself, please?
Absolutely. Thank you, Trupti. So I'm Amanda Welsh, and I'm currently a professor of the practice in the analytics program at Northeastern. I've been here for about a year. And my journey to data science began many moons ago when I was doing my doctoral research in linguistics. And at that time, linguistics, I was working in neural networks, trying to define natural language processing systems. We didn't have any of this vocabulary at the time. It was a really long time ago, but it was the precursor of what became in the field data science. And what I really enjoyed was parsing finding patterns in data and parsing the way patterns exist in data and how that then plays out and manifests itself in real world scenarios. So I very quickly adopted a very applied perspective for my data work. And that then ultimately led me through a number of data companies and market research companies, which are focused on consumer behavior.
Wonderful. It's incredible that we have professors from all three colleges at Northeastern University Seattle. Thank you so much for joining us today. Shivani, reflecting on your current work experience, can you please share an example of how are you involved in utilizing data to make data-driven decisions?
Sure. So in my current role, I work at SAP Concur, where we develop machine learning models for one of the products Concur sells called Expense-It. So in this product, you take a picture of your receipt and it automatically fills out the expense report for you. So my day-to-day work is really focused on a special use case of natural language processing applied specifically to receipt text. And so in that process, end to end, we're making data-driven decisions. And so although I'm not on the business analytics side of the product, I am utilizing data in order to understand how my model is performing. When I deploy my model to production, how is it doing in performance testing, as well as how is it doing in terms of actual model performance and hitting the target that we expect it to predict, how accurate is our model. And outside of work, we're planning this conference, and so we used a lot of data in order to understand our attendee patterns. And so if you get a bunch of women in data to plan a conference, of course, one of the things we're most interested in are attendee analytics. And so for the past few months, that's actually been a big part of how I've been making data-driven decisions too, is understanding who's going to attend our conference, what are they looking for, how can we measure engagement.
Interesting. Thank you so much, Shivani. Amanda, would you like to share your experiences, maybe reflecting on your previous work experience, and tell us more about how were you involved in utilizing data to make data-driven decisions?
Absolutely. So right now, you're right, I'm teaching primarily, but just before joining Northeastern, I was working at the Nielsen Company, which is best known in the US for its product understanding how consumers watch media, TV. Everyone knows Nielsen is the TV ratings company. Interestingly enough, that's only about 1/3 of their business. 2/3 of their business is actually in capturing what people buy at the grocery store. And what we were doing was processing tremendous amounts of data that we would receive daily from grocery stores all across the country. Indeed, we were actually collecting data from 160 different countries to capture consumer shopping behavior. But what we would do is we would help consumer goods companies who were making products understand what was selling, and if they made changes to their product, how that would impact their sales, as well as on the television side, how many people were seeing advertisements and how frequently and in what ways seeing an advertisement then actually connected to the purchase of the bottle of ketchup.
Thank you so much, Amanda. Adrienne, would you like to share your experience with all of us?
Sure. My experience has been very broad in terms of utilizing data science in the workplace. Ranges from building models using sensor data to try to pull out patterns of human behavior, or do activity recognition, physical activity recognition. It has included working with other data scientists who are building models, and we need to figure out how to deploy those models, how to build that data engineering pipeline to put those models into practice in a live manner. It's also been more internally applied, where we take some data and use that to come up with a targeted plan, for example, for salespeople to prioritize who they're going to go and try to sell to. So there's been a really wide range of the applied data science pieces.
Amazing. Thank you so much for sharing your experience, Adrienne. Wow, it seems like you all have such a wonderful work experience in the field of data science. Like, I feel you all are truly rock stars in your field at work. So this leads to my next question for you all. So when it comes to discussion of data science, no matter what background they have, like business, finance, medicine, engineering, agriculture, people easily get excited and they think data science is what the future all about. Data science is also a very hot trending topic in the media and amongst young professionals. However, do we really know what data science is? Data science in the past few years has been used to refer almost everything related to data. You may call it data analysis, data mining, machine learning. Also, it seems like its methods, goals, and applications has evolved with time and technology. So Adrienne, would you like to share your thoughts on your definition of data science, data engineering, and data analytics? According to you, how are they different and how do they manifest in the industry?
So I'm going to acknowledge that just because I'm going to define it this way does not mean that that's what anyone else agrees upon. And in fact, that's one of the first things I think needs to be defined whenever you're speaking to other data scientists, or to maybe someone in a professional capacity who's saying something like, data science is the future, that's what we really need. It's really important to tease that out and see what it is that they mean. So you asked specifically about data science, data engineering, and data analytics. I would roughly group it as data science is going to be, could be a little bit more on the research side, or the putting models into practice, maybe a little bit more machine learning oriented. Maybe doing some exploratory analysis of what data do we have, or if we had a certain kind of data, what would we be able to tell? Data engineering is where we're going to maybe building that pipeline to put those models into production, understanding what data is needed, and getting it into the format it needs to be in order to run it through those models. And data analytics, I would say is a little bit more on the prescribed side, where we're taking some data, trying to make decisions with it. And maybe I would consider this a type of data that is, we're collecting it over time, and we're looking for trends, and we're looking for something that's changed perhaps.
Mm-hmm. Thank you so much, Adrienne. That was quite insightful. So coming to Shivani, Shivani, would you like to add something to this?
Yeah, definitely. Like Adrienne said, it's really important to have this definitional conversation depending on how you're trying to use the definition of data science. So if you're someone who's looking for a job as a data scientist, really figure out, instead of trying to say, I want to be a data scientist, I think it's really important to read job descriptions and kind of target the types of work that you are particularly interested in. So for me, data science kind of means, it's come to mean at least, this broad umbrella that covers almost anything from like BI and analytics all the way out to data engineering. And I've seen job postings that have descriptions where they're calling a data scientist that does this whole range of skills. And one of the things is that when it comes to data science, and as our data warehouses and what we ask of our data grows, I think every employer is looking for people to be really curious, which is where like that science word kind of comes in. There's no well-defined questions anymore. And so we need everybody to be a scientist in the sense that they are doing a lot of exploratory work and figuring out what is the right question that we need to be asking in any data related role that they are in. And so when it comes to defining data science, I think the best thing that you can do is read about the different roles that you are interested in and kind of start to narrow down the aspects that sound most interesting to you. So if you are really looking to, if you enjoy data visualization, you enjoy analytics and delivering business insights, then don't look for necessarily data science postings. Look for those keywords that say analytics, insights, product metrics, those types of things. On the other hand, if you really enjoy the engineering components, you enjoy building those ETL pipelines, you maybe want to manage clusters, you want to make sure we can do distributed computing, look for those specifically, because data science could be anything at this point.
Thank you so much, Shivani, for bringing some clarity and sharing your perspective on this. So as Shivani mentioned, that data science is a broad term and like everything falls under one umbrella. So which can cause a lot of confusion when a prospective student is trying to get a data degree. So as more and more people are seeking data science education and more universities rush to develop programs, there can be some confusion on what differentiate these programs. Now talking about the broad field of data science, Northeastern University itself has 3 different programs focusing on data science. Dr. Amanda, what do you think about these programs and how are they different from each other?
Yeah, that's a really good question. And I really appreciate what Shivani and Adrienne have said about data science being a catch-all phrase. We all use data. Data touches everyone in a lot of different ways. So it is a very, it's a word that means a lot of different things. And it's often hard as an individual to figure out what your particular path is going to be. I think the council to understand specific components within data that's interesting to you. Am I interested in the applied use of data to drive business decisions is important. Am I interested in using a suite of tools to construct a data solution, to build something is important. And then finally, am I interested in thinking about data and data types that can be collected and the tools that we use to work with them and coming up with new tools and expanding an architecture for data is a third way to think about it. And while all of the degrees at Northeastern will provide a tremendous background in data, generally speaking, at a very rough level, if you're interested in the applied, then the analytics degree is a good one for you. If you're interested in really focusing on building things, then the computer science degree is probably the area to look at closely. If you're interested in more of creating a new architecture and redefining the tool set, then that might be more of an engineering approach, and that degree might speak to you a little bit more.
Mm-hmm. Thank you, Amanda, for providing clarification on Northeastern University's 3 graduate programs. It's wonderful to learn that Northeastern is providing different programs related to data science, which provides students flexibility to select their program based on their career interests. So moving forward, from a career perspective, for the 4th year in a row, data scientist has been named as the best job in America by Glassdoor. From healthcare to software to real estate and financial services, the skills required for data scientists are in demand across industries. So having said that, data scientists are expected to know a lot, naming from machine learning, computer science, statistics, mathematics, data visualization, communication, deep learning, and so much more. Amanda, like according to you, what are the key skills that people should possess in data science? Moreover, like what do you look for in a data scientist? This can be technical or soft skills.
So my number one answer is going to be to double down on the word scientist and say that a key characteristic is one of curiosity. And, you know, when I was in graduate school, data science didn't exist as a field. I was sort of doing it, but it has certainly matured over time. And I've been able, in the course of my career, to continue to learn new things and to continue to train myself in a formal academic setting and outside of a formal academic setting. And it was the curiosity. It was coming up against a problem and saying, gosh, what if? And then pulling on a thread and doing some work that helped deliver that. And, you know, I think even when you are freshly trained, freshly minted master's or PhD student, and you have a number of skills, hard skills, technical solution solving, problem solving skills in your toolkit, you still have to approach any particular problem and say, is this the right approach? Is that the right approach? And I'm going to try each, and I'm going to play, and I'm going to be curious to find the right ultimate outcome. So I would say that curiosity is the number one skill.
Thank you so much. That's really great information to know. Adrienne, what is your perspective on this?
I'm going to double down. Amanda just said it. Shivani said it. It's curiosity. I would add just behind that humility and perseverance. You need to have that humility to ask yourself over and over again, is this the right answer? Is this the right approach? Is there something else that can explain what I'm seeing in the data? And you have to have the perseverance to keep going, because sometimes things just don't look like they're going to work out, but you just gotta keep digging at it.
Yep, totally. I totally agree. And it's so important to ask the right questions that I feel at times. Like just being so curious to ask the right questions, and I have faced it myself. Shivani, like, do you have a different take on this one?
I'm actually going to triple down on the curiosity and agree with my peers here. And that is because one of the things that I really found in my course was helping students move from this idea of them being told what is the question I need to answer, to them making the mindset shift to how do I understand what is the question I need to answer without being told what's the question that I need to answer. And that comes from, I think for me, a deep understanding of data literacy. And that's what separates the candidates that I interview. And I feel when I say data literacy, I know that's kind of confusing, but I mean, can someone look at a data set and understand what insights can be gleaned from that data set? So for example, I teach statistics. And so one of the things that I see with my students is helping them make the transition from, here's a data set where you can complete a t-test, please complete a t-test, to here's a data set. What are the statistical tests that you can utilize to analyze this data set? And as a data scientist, you need to be able to look at data in industry and say, oh, this is the analysis I should do. Or this is going to be an inappropriate analysis that's going to yield inappropriate results due to X, Y, and Z factors for the conditions of my test not being met in this particular case. And so I think really moving beyond that checklist mindset, like I've done 8 Kaggle competitions and I've completed 12 projects. And if in every single one of those projects you've completed someone else's analysis or someone else's guidance on the analysis, that's like the shallow level. I wouldn't really consider that true data literacy. You want to move deeper, and I know that feels scary sometimes because you're like, am I doing the right thing? But that just comes from experience and playing around with data, and then asking your peers, asking professionals, asking around to learn more, and having that curiosity mindset to say, am I making the right choice here? And if I'm not making the right choice, how can I learn from having made the wrong choice?
Thank you so much, Shivani. That was great information. Like, I totally understand the importance of like data literacy, and it's so important to have it like in the data science domain like that we're talking about. So now on the similar terms, talking about challenges, there are few common challenges that a data professional face when they're new to the data science industry. As we discussed, data science requires a diverse set of skills. It is an interdisciplinary field that draws on aspects of science, math, computer science, business, and communication. Within those areas, there are dozens of languages, frameworks, and technologies that a data scientist could learn. And here comes the challenge. At times, we don't know where to start from. I would like to know from our panelist, what would be your advice in addressing this challenge regarding the skills or tools one should focus on who is planning to start their career in data science? Amanda, would you like to share your thoughts on this?
So in terms of particular skills or languages or frameworks, certainly Python is a very good technical framework to explore data. But I will say, and again, I go back to the fact that I've been doing this for a really long time. I just want to encourage everyone to know that the IT language in my career changed 3 times. So there is no such thing as learning the right tool. And the best thing that you can do is understand, just embrace that you are going to have to learn more than one tool. And the best thing you can do for yourself is to look for generalizations or commonalities from tool to tool. Every data language is going to require a method to ingest data, a method to describe data, a method to combine data, a method to delete data. And if you can establish that common vocabulary, then there'll be specific particulars that one language is better at than another. And this then gives you that instinct or insight about how which language to deploy, which one to begin to learn and understand. You can clear away the noise of the general stuff that every tool and every language needs to provide for you, every toolkit.
Thank you so much, Amanda. I think this is where the curiosity and the ability to learn quickly to new tools, technologies, because things are changing so fast. So thank you so much for sharing that with us. Shivani, what is your take on this?
Sure. So kind of going back to the last question too, I think in terms of soft skills, one of the important things that I think every data scientist now needs to focus on is data ethics. And even if you think that you're not going to be working in a field with human data or any data that might have an impact on humans, I think data ethics is really important because we're at this kind of pivotal moment where we have so many rules and regulations around privacy and security finally coming to the forefront. Like our legal regulations are slowly catching up to technology. And so having that understanding of how do I work with data in an ethical manner is really important. And part of that is understanding bias in data. And the reason why I think that's really important for any data scientist, regardless of whether or not you're going to be working with human data, is because it makes you a better data scientist. I don't work with data that can negatively impact humans, but understanding bias and imbalance in my data sets makes me a better data scientist regardless. And when or if I change careers or end up in something where I am working with human data, it allows me to recognize that. And I think that that as we talk about higher education and data and forming these new programs, the like courses on data ethics, or if your course that you're in doesn't offer a data ethics class, kind of reaching out and looking for those opportunities on Coursera or elsewhere to kind of broaden your horizon. I know that when I started thinking about data ethics, there's still so much I don't know, but my first course that I ever took, or my first book that I read, really expanded my horizon. So I would recommend everybody check that out. And then another soft skill is presentation skills. So regardless of what data field you end up in, if you cannot adequately communicate your insights to your stakeholders, it is going to be really difficult for you. So and if you are not someone who enjoys presenting, who enjoys communicating, you just really enjoy the data part, find ways to help get over that barrier. And the great thing is we have so many meetup groups now, so many opportunities to do things like lightning talks, where you're just committing to giving a 5-minute presentation to strangers. So even outside of your professional experience, you can kind of get comfortable talking about data and about your projects to groups of people, because that's going to be really key, especially in industry, as you start to advance your career and move out of your first year of being a data scientist. And then in terms of technical skills, I would say one of the ones that going into a graduate program for statistics, the one that really I had to work on was my Unix and Linux skills. Like coming into working in machine learning, my statistician brain had to pick up those skills, and doing that made me way more efficient than if I would not have picked up Unix and Linux. Like there's so much that happens on the terminal still, in terms of every data scientist, even if you're not engineering, you are learning some level of computer networking, you're SSHing into machines, you're doing things where you need to be proficient in your shell and feel really comfortable in that space. And for me, that wasn't a class that was a part of any of my learning in math, right? Like Unix and Linux wasn't something that I did. So I went out and found a Unix and Linux course that was like a extra credit kind of thing I could take as part of my graduate program after my internship at SAP Concur, to help solidify those skills and just learn a little bit more about grep and SED and all these tools that can help you out when you're in a pinch. So yeah, that would be my one kind of offbeat technical skill I would recommend.
Thank you so much, Shivani. That was very insightful. So now, like talking on a similar terms, like talking about challenges, like in a recent article, I read that Forbes mentions that STEM, data science and AI are the fields in which women are like vastly underrepresented. And the numbers make it clear, like females compose just 28% of the science and engineering workforce. And the number drops like when observing the number of women pursuing university degrees in the SAT fields. Now talking about challenges specific to women, some key challenges facing women in data science include gender bias, stereotypes, and perception. One of the biggest pressures that women face in STEM is cutthroat competition amongst male counterparts, and the toxic workplace culture that it creates. Few women at times think of data science as a male-dominated industry. So again, coming back to you, Shivani, how do you make your voice heard in order to be seen as a leader and get ahead as a woman in data science?
So much to unpack in that question. Your intro was really good. You covered a lot there. So okay, so first I would say, if you are starting off in your career fresh and you find yourself in a toxic workplace, put energy into getting yourself out of there. There are some things you can change and some things that you cannot change, and you can do what you can for yourself, but the best thing you can do as a woman, as a man, as anyone in your first year, is start your career off on a path where you feel supported, mentored, and if where you land first isn't that place, figure out what that place is, or find a new role that helps you get that mentorship, because your first 3 years, being able to work and grow in an environment that's supporting you is really going to set you up on a great path to succeed. So that's one, if you're just starting off. And then in terms of feeling like I have support, I am really involved in the women in technology community. And through that, I've met a lot of women who have been really open and honest about their struggles. And I've been able to, in turn, be honest about my struggles in different formats. And so talking about those things and getting involved in a community and finding that support system. So let's say you end up in a situation where you are in a toxic workplace, you're not getting the support that you need. Look for that community outside of your workplace if your workplace isn't going to provide it for you. So that could be Pi Ladies, Our Ladies, data circles, conferences like this, messaging people on LinkedIn that you admire, as long as your message is well thought out and respectful, can be a great way to maybe connect with someone that you can learn from. And then finally, don't underestimate the importance of your technical skills. Like at the end of the day, we are all data scientists. And I think WiDS said this in her talk, the 7 years, seven takeaways in 7 years of data science. That was a really great talk. And she, her emphasis was the base is your technical skill and what you're contributing technically to your team and your company. So keeping up with the latest trends, making sure that you're continuing your education all the time, continuing to be a curious and engaged learner, that will also help you.
Thank you so much, Shivani, for sharing your perspective on this. Adrienne, would you like to share your thoughts and your take on this?
Yeah, I'm going to start with agreeing with Shivani that those first couple of years after you finish your degree are really important, and you should be in a place where you feel mentored and where you feel like you can grow and that you're not alone. I think that's really, really important at the very beginning. I think the other piece there is the community, making sure to have friends and a support network both within your organization if possible, but certainly outside of your organization, where you can get some perspective on a situation or get an outside view if you think that something might not be going well. Get some advice on how to approach it, how to make the situation better, what you can control of the entire situation. And I think in the end, I think we need to look out for each other as well. We have seen in the past that sometimes it's women trying to push other women out of the way. I have not seen so much of that. I've heard of it, but I do think we all need to be aware of the other women around us, and we need to support each other. We need to make sure all voices are heard, not just women, all minorities, everyone in the room.
Thank you so much, Adrienne. Support is very important, especially when someone is beginning their career into data science. Thank you so much for bringing that up. And if we support each other, we all will grow at the same time. So I think it's really, really important. And thank you so much for highlighting that. Amanda, would you like to add something to this?
Yeah, actually, I have one thought, which is to kind of turn the conversation upside down just a little bit. And to say, hey, this might be a career path that presents some challenges to you. But you know what? It's an important thing for you to do. And therefore, you should go for it and push. You know, when Shivani was talking about bias in data, that's so real. And it isn't, and we encode bias in data so easily. You know, the old rule of thumb, 80% of your time is in data cleaning and preparation. 10% of your time is in doing the sexy algorithm stuff, and 10% of your time is trying to explain what you've done to somebody else. It's in that 80%, which is a ton of time, that you make a lot of decisions in cleaning your data. What do you suppress? What do you allow? What gaps do you reasonably allow in the data? That you make a ton of decisions that encode bias. And different people from different experiences will naturally encode different biases. They'll allow, different things will look reasonable to them. And so it's incredibly important that we have this range of voices represented. And as women, you know, we represent a pretty, you know, sort of demonstrable voice. And it's just super important that that voice be present. Just to provide one little example, I do still pro bono work in the literacy space and work a little bit on literacy rates around the globe and in developing nations. Well, guess what? Nobody thought when we were collecting data on how school children were performing in elementary schools that had been built over the past 20 years to code gender. So we can talk about literacy rates at the country level or at the city, state, or even school level. We cannot talk about how girls fare compared to how boys fare. And I kind of wonder if a woman had been sitting in the room during some of that initial data design or project design, if indeed we wouldn't be struggling now to close this gap in the data that we have to work with.
Thank you so much, Amanda. Those were indeed some amazing insights and tips that you provided to all of us. Like many of the women I met, I feel they just lack a bit of confidence, and I feel they need a little nudge to believe in their abilities. As women, it's very important we understand what opportunities are available to us in data science and what those opportunities involve and what the quality of life looks like for someone in this role. So the conversation was very, very insightful. Thank you, panelists, for sharing your experiences and your perspective on different fields of data science, on things that should matter to data scientists, and to, you know, how can someone enhance or develop the skills when they're in the beginning of their career phase. And so like talking about, like earlier we had a conversation, like coming back to my previous question. So we talked about differences in, like, you know, data science, like how do different data analytics, business analytics, data engineering, data science, how do they differ? But I would really like to know what is an overlap between, is there an overlap between those, you know, those different domains? Like if yes, if there is like an overlap into it, then I would like to know more about like what someone pursuing their master's in data analytics should learn from a data engineering course, or like I just would want to know how things overlap and how can someone enhance their overall skills that way. So Adrienne, like I would like to know from you, like what are your thoughts on that?
Great question. So this kind of relates back to what you were saying earlier in terms of what tools and technologies someone should learn. And I would say to some degree it doesn't matter, building on what both Shivani and Amanda said in terms of the technologies change over time and you need to get comfortable learning something new. But I would say whatever it is you learn at this point, learn it deep. Find one thing to grab onto and go deep in, double down on that. This is the same advice we give computer scientists when, young computer scientists, when they are just starting out. The big question is, what programming language should I know? And the answer is you should know all of them, but you start with one and make sure you know it really, really well. And then all of the rest fall from that. It makes it every single one after that is a lot easier. I think thinking about the cleaning side of things and Shivani's comment on the Unix and Linux tools, because that is hands down the easiest set of tools I've ever used to actually get my data into a clean spot. So I would make sure that you're pretty comfortable writing scripts and using Linux or Unix, whichever one you want to call it, and knowing all the tools that you have available to you to handle that data.
Thank you so much, Adrienne, for sharing your thoughts on that. We have one question, and this is to you, Amanda. If I'm reading the question for you. So if 80% of the time is in data cleaning, does that imply that data engineering should receive more focus in all graduate programs, even in data science and data analytics program? Like, because we all know that data cleaning takes most of our times working on the projects. So what are your what are your thoughts on that?
Yeah, I would say that when we talk about the programs and we come up with a checklist of the skills that you will possess being a graduate of the program, we don't necessarily say that data engineering, feature engineering, I think we might put on some of the lists, but data cleaning isn't something that we put at the top, right? The reality is, however, every project that you do, every assignment that you work on has some element of data cleaning. You can't get away from it. So I think the answer would be you get ample exposure and experience in data cleaning and understanding the implications of certain decisions that you make. I know that in one of the courses I teach, we deliberately provide a very messy data set to students. And different students will make different decisions in how to clean up that data to provide a result. And inevitably, some of the class gets one result, some of the class, given the same input data, comes up with a diametrically opposed conclusion. And that's a function of the different decisions that they've made along the way. So I would suggest that, yes, it should be a big focus of the programs, and it is. We can't get away from it. We do call it out consciously a little bit, but I think it is implicit in all of the work. It just may not be one of the things that we say, upon graduation, you know how to code in this language and understand this statistical technique. But the reality is you get a lot of data cleaning training.
Thank you so much, Amanda, for sharing your thoughts on that. And so we have another question from one of our participants. So here the question goes. So I'm directing this to Shivani. So that participant says, if I do not have time for a full degree in data science, I had computer science degree 2 decades ago and work with general data analytics in finance, how can I learn most efficiently to contribute to my work? Shivani, would you like to share your thoughts on this?
Sure. So I talked to people at my company who want to make the transition to data science. And I say one of the easiest ways you can get started, if possible, is to talk to your current manager in whatever role you're in to see if there's any data that your team is currently working with that you can do a side project on. And usually the reason why your company's data is a great place to start is, one, because you might have access to it already, and two, it's something that will actually go back to benefit your current role and allow you to kind of build rapport with what you're doing at work. So, and this depends with the kind of role that you're in. Obviously, you know, if you're in sales and you want to transition to data science, this might be a little bit harder. You might not have the same data access, but if you're in BI and you want to transition to machine learning, you have access to the data already. So how can you come up with a project, a little project that you can work on in maybe 5, 10, 15% of your time to work towards those skills? Even if you are in sales though, I think with so many companies becoming really data focused, there are opportunities if you ask and you are persistent to say, can I do something here? Or can I work with our sales analytics team or our finance team to explore this? And more companies have programs that allow you to give a little bit of your time to something else or a fellowship. So look for those opportunities, because applying it in that real life setting is so much more impactful if you're already working than doing a competition on Kaggle or something like that, where you already have like a clean data set that's ready to go and you're working on it. Like, you are getting real hands-on experience that way. Does that answer the question? It sounded like that person was already working, so I was kind of trying to gauge.
So talking about this, like you just mentioned doing some projects online, right? They already have clean data. So what do you think about like boot camps versus degree programs? Like,
right. Okay, so this is a really, really great question. And I am biased. My own bias is degree programs that are kind of like what I call the cut and dry degree program. So my master's is in statistics. And so I'm a big fan of like the statistics, computer science, you know, kind of like those cut and dry disciplines. But that doesn't mean that they are necessarily the right choice for everyone. So one of the things that I love is that there are so many programs available now and offered on so many different schedules to help you make the right choice for yourself. And there is really no right or wrong answer here. Everybody has to factor in for themselves the cost of each of these programs, the time that they have to dedicate to it, and then in the end, what are you trying to achieve with the program? And really, really giving yourself time to think through, is the program that I'm going into gonna give me the end result that I want? So let's say, and I have to, even though this is a panel for graduate degrees, I have to say, I talk to a lot of women who've been working as analysts for 7 years, and they already have a master's degree, and they're like, should I go back to school to make the transition to data science? And I am like, no. You have the skills you need to do the job. So don't sell yourself short also as you're considering what skills you have. But you know, think about, if you are someone who learns better in a classroom setting where you have time to digest information, a master's degree in analytics or data analytics engineering, or a night school for a master's in computer science might be the right choice for you. And then if you are someone who has 3 months to dedicate to a boot camp, that might be the right choice for you. So it really depends.
Thank you so much, Shivani, for answering this question. So my next question goes to Amanda. So here's a question. What recommendations do you have for communicating data analysis to a non-data people?
Oh, I love that question. First, however, if I could just go back to the boot camp versus the degree, I did want to add one observation. I don't know if Shivani would necessarily agree with this, but I think that to some degree, boot camps are such a compressed time period, they're offered in such a compressed time period that they're really primarily focused on skill acquisition, whereas a degree gives you skill acquisition as well as a greater degree of mentorship from seasoned faculty or professionals, as well as networking opportunities. So I do think if someone is in a job and they're looking to grow to the next level of the job and they already have a network and whatnot, a boot camp might be a very, a good solution. If you're looking to enter a new field or switch fields or change location, then that degree really does offer sort of a broader array of value and support for you. When it comes to talking to non-data people, the thing that I have learned through painful trial and error is that analogies are worth their weight in gold. And that if you can distill whatever you're trying to communicate into a very simple analogy, it's kind of like, it's apples and oranges is an example of one. It's really very trivial, but it just grounds the whole dialogue for someone who otherwise will get very confused or intimidated or geek out in not a very helpful way on some of the technical aspects of what you're trying to do. So A, you're extra clear on what you're trying to communicate if you have to reduce it to an analogy of some sort. And B, you really keep people focused on what you're trying to communicate. Because I can tell you countless times I've been dealing with senior executives who really didn't understand the details of the data and didn't have the patience to want to understand the details of the data, but wanted to look smart. And so they would walk away from the conversation with me and then go to the next executive and say, oh no, it's not apples to oranges. And then they'd feel very smart. And then I was very effective in communicating. They got the point, and they were able then to carry that point on through the sort of business ecosystem.
Thank you so much, Amanda, for sharing that with us today. So coming to our last question for this session. This question is from Gayatri, and I would like to give it to Adrienne. Adrienne, the question here it goes, is cloud computing a desired skill set for future data scientists? What are your thoughts on that? Sorry, I think you're on mute.
Absolutely, yes. So there might be a little bit of a depends exactly where you are and what your focus is on, but I would say that absolutely you should understand what is happening with cloud computing, what it gives you, what constraints it has at the very least. But in the bigger view, I would say absolutely. I think everyone needs to know what's going on with cloud computing these days.
Thank you so much, Adrienne. I think we still have questions, time for one more question. So Shivani, this one is for you. So you talked about soft skills earlier, bias in ethics and such kind of things. And there are a lot of, so coming to a program specifically, not everything is taught in a specific program, right? There are a lot of skill set that someone needs to develop apart from their classes or apart from their work. So what are your thoughts on it? Like, how can someone, so considering one, I'm someone, pursuing my program at some university or something, but like, how should I develop my skills apart from those courses that are being taught in my school or in my class?
Technical skills or non-technical skills, or in general?
In general, like what is your recommendation to develop these skills if they aren't specifically taught in the program? So,
okay, sure. So listening to panels like this was really helpful if you're trying to figure out, but for, my example that I gave earlier was that I found out that I really needed to brush up on my Unix and Linux skills, and because I was already enrolled in my master's degree at that time, I did a cross-departmental search, and so the Unix and Linux class I ended up finding, and this took me time, I had to read through the course catalog to see, what was out there, but it ended up being actually taught through the microbiology. And it was taught through microbiology because they were doing some work on genome encoding. And so they had a Unix and Linux class specifically for their PhD students that I was able to wiggle my way into to learn. And the reason why I found out about Unix and Linux was through my internship. And so now you all know that, and you can do a search like that for classes that might be cross-listed to see if you can wiggle your way into learning them. And then there's so many great resources available online. And I know that learning by yourself sometimes can be difficult. So this is difficult for me. Like, it's hard for me to just sit with a Coursera class by myself and do it. But if I reach out to my community, Pi Ladies, R Ladies data circles, and I say, I really want to finish this class on Coursera. Does anyone want to be my partner in finishing it? Then I am like 75% more likely to actually get through that class because I have someone to actually discuss the material with. And in independent learning, that's the thing that I miss the most, is when I have a question or I want to bounce ideas off of someone, that online format just doesn't work for me. So finding the community is so helpful. And I feel like the community really is like the crux of everything. Like, as I continue to grow in my career, I'm able to grow because I'm a part of this community that helps support me, helps open up my eyes to ideas, tools that I haven't maybe thought about expanding. in, and then they encouraged me to take risks. So I'm here on this panel because I have some awesome mentors who have told me to do things like ask for what I need to grow and to remember that it's okay to fail. And so kind of putting all of that together is I think really helpful. So find your support system, as Adrienne and Amanda mentioned in their points as well.
Thank you so much, Shivani, for bringing some clarification onto this, because like it's wonderful to know that like there's a lot of work to be done apart from like your program, or like, you know, you just have to be continuously be learning things, just observing things, doing various projects, and, you know, working that way. So thank you so much, panelists and all the attendees for joining us today. We definitely need events like these to create a field that is more inclusive and welcoming, to give women a chance to talk about our experiences and educate our allies. Opportunities for women to connect and support one another are vital, specifically to retain women in the field of data science. Thank you so much, everyone, once again. It has been wonderful.
Thank you.
Thank you, Trupti.
That was wonderful. Thank you for the opportunity.
And thanks for the questions, everyone.
Thank you.
Thank you.
Right, so that concludes